Okay. All right, let's go ahead and just put a function here. And well, you guys have written function like this before, so you kind of know what's going on. But that's pretty much it for functions. Now let's go ahead and work on the
Where's the first function? There are two functions, right?
No, we did 3 functions. The split data function called target features, where we split stuff into train, test, validation. And then we have function for cleaning up the data frame. It's out of order, but it doesn't matter though. So if we look, I like to reference my old code, if you can't tell already. So this is kind of like the class that I wrote. As you can see, the structure is very simple. We define the class, and then we initialize the class. This right here is very, very important. You can put stuff right here under init, but that's not necessary. You can just do pass. Pass just means we didn't put anything inside this function for a reason. If you don't put pass, this will throw an error because it should be like, oh, this function is not complete. You know? Did somebody join us? What happened? I don't know.
No, my laptop made a noise, sorry.
Oh, okay. I was like, what's going on? So you have to put pass so that this won't throw an error. All right. So let's go back here. You know what? Why am I even doing this manually? Always copy your own code. I promise you, it will save you a whole lot of time. So the basic structure of a class is basically you have the class, right? And then you have the class name. And then you initialize, you have a function that initialize the class, and then you have different functions. Okay, so inside a class, a function is called a method. Okay, so function and method are the same thing, but they have different names depending on how they are. So outside a function like this, it's called a function. Outside a class, it's called a function. Inside a class, it's called a method. Does that make sense? Cool. So let's just go ahead and put pass. So let's call our class. Do you guys want to? So let me show you something. In this situation, I created multiple classes. Do you guys just want to create one class and with multiple methods, or do you want me to create multiple classes? I mean, it doesn't really matter. What do you think? One class, multiple method. Okay. So we initialize the function right here. This doesn't look right. Wait. Does init need self? Yeah, it does. That's what I thought. Okay.
So nothing goes in the init.py file at all, or?
I mean, yeah, you can put stuff here. I mean, I didn't in this situation, but I think
we can put them in
this other project. I had something in my init. I had something here. Okay. You know, I don't remember why I put stuff here though. Like if our package throws an error, it's probably because we didn't put stuff here. But I don't think yeah, I don't remember. There was a reason why I put stuff in my init file in this case, but I don't quite remember the reason why. But we'll just leave it out for now. And if we get an error, when we try to import the file, then we'll come back and just add the init file and re-upload the package. Okay. Yeah.
Yeah, it can be empty because like it's just the existence of that file in the hierarchy of files
Mm-hmm.
it treats anywhere that init is and the file is on the same level as it, it treats it as package, module, or whatever.
Oh, okay, that makes sense. Yeah, because I remember, I don't know. Yeah.
Yeah, it's the existence of the file, not the contents of it.
Okay, yeah, that makes a whole lot of sense because I have some packages that have stuff in it, and I have some packages that doesn't have stuff, and I don't remember why I did that. So, yeah. So let's create. So this, basically this self right here is basically referencing this object, like this method, right? This self is referencing this method. Let's give this a different name. Let's call it no. Let's call it easy data. Okay, so you know, I didn't want to use name because I think name is a keyword, and actually name is not a keyword, but I don't like to use stuff that are keywords in Python, you know, to name stuff. You might, you know, run into errors. So basically we don't have to rewrite the whole thing, but let's call this let's just take this function that we already wrote right here. So basically this is what a class is. A class is just taking your functions and putting it in a class, but the difference is that you have to add self here. You know, so if you have a function that you already wrote, you don't have to stress, oh, how am I going to create a class? Just take it and put it right here. So when you do that, then you have to do self.df is equal to df. So basically you're saying that whenever this data frame is referring to the data frame under this object, like just know that if you don't put self, nothing is going to work. So in this case, we have to do self dot, we have to self everything. That's the main difference between a function outside of a class and what we call a method, you know, which is a function inside a class. Everything starts with self. And I'm just going to check my other code to verify. I like to check my old stuff for verification. Let's see. Sure, let's add a doc string. Sounds fun. Huh. Okay. Yeah. Basically, so that's kind of like the main difference between a function outside and inside. So do you guys have any questions about like method? Do you guys understand the difference between a method and a function? I'll take your silence as a yes.
So you need a self behind train as well in the line 26 inside the parentheses.
Yes, thank you, because we would have run into an error.
So why don't we have a test self behind train test display, the train test display function?
Train test split is not a variable.
Oh, okay.
Yeah, train test split is its own function.
Okay.
From scikit-learn. Yeah, so I forgot to put random state again. So this train test split that we have here is a function. So basically, this is how you define. This is how you define a variable inside a method. You put self dot the variable name. Okay. So the train test split is not the name of a variable. Does that make sense?
Yes. Yes.
Okay. Random state. And you know what random state means? It just means every time that you do this split, I want to get the exact same result. Let's go ahead and add random states everywhere that we need it. I don't know, should I name this separate though? None of this will cause an error. Let's call this just to be on the safe side. If you think something is going to cause an error, just rename it, you know. Okay, so I think everything looks good there. And let's add random states here too. Okay. And let's just go ahead and put this to GitHub, git add. Okay, so we are good there. And let's just go ahead and take all these functions that we created and put them in our class and put self dot everything else, you know. So I just wanted to, you know, make sure you guys understood that classes are not that complicated. I mean, they can get really complicated. If you watch the video from Corey Schaefer, you know, he covers stuff like decorators and stuff like that. Well, we probably won't cover that here. I just wanted to show you kind of like the basics of, hey, this is how you go from A to B to C to D. So in this case, we do self is equal to target. Self.futures is equal to self.train.columns.drop target. Okay. Is this, so we have self here, we have target. And what are we putting as inputs? I'm trying to see train features. So that means that we have to pass in no, we can do that up here. And now let's just do it here for clarification. So we need to tell it what is our, we need to give it the training data set, the validation data set, and we need to also give it the test data set for this function to work. All these self.trends. This is just too many self.. The first time I took this class, I was really, really mad and frustrated because I didn't know you had to self-dot everything. And I didn't know why my functions were not working.
So pretty much every variable, we're doing this too.
Yeah.
And the reason we didn't do that to the train test split because obviously that's the function itself.
Yeah.
Okay, that makes sense.
Yeah.
So you don't actually need to self everything. You only need to self the ones that are actively being stored by the class. So like if you have a variable that is specific to that method alone, you don't actually need to self it. Like it can refer to itself like that. The only time you need to self is if you're actually overwriting the class variable like as a whole. So
like you mean what do you mean?
So the stuff that you would normally pass into a init. So that's the stuff you need to.
So you're saying if I pass in let's say data frame up here.
Yeah.
And then in here do self dot data frame is equal to data frame.
Yeah. And then you could
Okay.
Yeah, and then you could basically say the self.data frame is that one. So you wouldn't have to pass in the data frame to the methods because you would have it in your class.
Yeah. So I wouldn't need this right here.
Right.
And then
because that's what I did in mine. Like I actually screen share what I did in mine.
yeah, that makes sense. That makes a whole lot of sense. Yeah. But I kind of want it in this because like whenever I call this particular method, I want to be able to pass in the custom data frame.
Like I don't think you'll break anything if you just self everything, but then again, yeah.
Yeah,
like
I mean, if you had
of,
like a function, like if you had a function called, I don't know, let's say, I don't know, hi is equal to, okay, something like that, and you're using this all over your method, then you don't have to self dot every, you could just be like self, dot hi is equal to hi, right? And then you can just use hi, let's say, you can just do hi here. You don't have to do self dot hi, for example, right? Yeah, but yeah, when I call this method, when I instantiate this class, I just want to instantiate it without passing in any variable. Like, because if I put df right here, then when I instantiate this, then to ask me for what df is, right? Yeah. So, but I want to be able to instantiate without passing in any variable at all.
Okay, that's
so yeah. So when I call this class, I'll give it a custom data frame, and then when I call this class, I'll give it the target, the train, the validation, and the test stuff. So actually, I want to put this at the end for a reason, because the target is going to be a string. And the way functions work is they want the variable names before they want a string. But that's a whole different, that's an error I run into today. But anyway, so self.target, so we want to say the futures is equal to train.drop. And then we are doing x train, x, y train. And then we want to return this. So I think this one is very much complete. This needs to be moved up one level, right? Is it on the same level? Yeah, it's on the same level now. Okay, so we need to all right, so X here is going to be my data frame, because my goal is to pass in a data frame. I should just probably call it data frame. My goal is to pass in a data frame, and then I want to clean up the data frame, but I already know which data frame I'm going to use, and I know this is a cleaning process to clean up that particular data frame, so this works. But the work you are doing on your own, you probably don't need a method for cleaning your data frame, but because you don't know what needs to be cleaned, beforehand. So you know what? It's just too much work to change all these X's into. So, do you guys have like any questions so far?
I have to run an errand. Can you post a video on our channel after it's done?
Yeah, definitely. Like when all of this is done, I'm going to post it in the channel. Hopefully it's.
This is really good. You're making way more sense than what we had this morning. So thank you.
Yes.
Yeah.
Agreed.
Okay.
Yeah.
Take care, guys.
Yeah, once again, I don't think you have to pass in all those X's unless you want to get the X from the class.
That is true.
itself.
Unless oh my, that makes so much. Unless I'm returning it right here. It's not like necessary to do the self dot. Like, I mean, I'm going to need it. So it's equal to. I mean, I'm going to need it here. No. Okay, this is all I need at the beginning.
I don't think you even need that.
Really?
I think the whole thing would work without any selfs because you're not pulling anything from the major class itself. It's just you have a method in a class without actually referring to any of the class variables.
Yeah. I don't know. It might, but I've just got into the habit of instantiating my variables with self dot equal to this, because sometimes it works without doing this, and sometimes it works without doing it. So I just do it to be on the safe side.
Yeah.
That
Can I
makes
actually
sense.
show an example of what I've got?
Yeah, go
Just,
ahead.
all right. And is that it? Yeah, that's it. All right. All right. So this is my train test split method. So as you can see, I actually pass in the data frame to the class itself. And with this, I don't pass in the data frame to that. That's because I call the data frame with self. So then I store the length here as just normal variable. I have a number stored here as just normal variable. I have even train, test, and validate stored as normal variables, just because they don't really need to be stored in the overall class. So when I call data frame splitter dot tvt split, and like I pass in the data frame to the splitter itself, then it's dot tvt split, and then I get back 3 different data frames there.
Hold on.
So
Go up a little bit more. Let me see how you instantiate everything at the beginning.
Okay, it's just
So,
init.
in the init, you have self, and then you have the data frame.
Yeah.
And then self.df equal to the data frame, which makes sense. And then you do length equal to self.df, and then
Yeah, so this actually doesn't change anything with the data frame itself. I'm never setting anything on the data frame. What I'm doing is using that data frame and returning 3 new data frames right here.
Yeah.
Now, I do have an example where I am changing the data frame, and that's down here with getting a date time split. So it'll give me new columns for every single one of these. So you see I'm returning self.df, and everything I'm doing is modifying self.df. So these are modifying the data frame.
It's modifying the original variable that you passed in.
Yeah.
Versus not modifying the original variable that you passed in.
Right.
That makes sense. That makes sense. See, I've
So,
always done it with what? Go ahead, Kelly.
I was just gonna say, so isn't it when you're trying to access a specific instance of the class, and so it doesn't matter, like when you were doing it, you weren't necessarily trying to access each individual instance. Like the first example mostly, does that make sense?
Yeah.
Or is that correct? Like what I said?
Not trying to access each individual. I'm not entirely sure what you mean.
So what self is doing is accessing the specific, because like every time you instantiate a class, you're creating a new instance of that class.
Yeah.
So if you're then calling self on it, you're then wanting to change something for each instance of that class.
Yeah.
So that's the only time we would ever need to use self. If we're not changing or trying to access something that's different for each instance, then we wouldn't need to use self.
Yeah. So something I can actually do to demonstrate is if I were to do like if I changed all these trains to self.train, what you would actually be able to do then later on is when you're calling the specific object here after you've run this is do data frame splitter dot train, and because that would be a new variable stored in it, so it wouldn't be tied to this specific method alone. It would be a variable tied to the class itself.
Yeah, see, all of this is so complicated. It's like, when do I use self when I don't use self? So I got into the habit of selfing everything, so that I feel like that's just kind of like the safest method. I mean, your code will be a little bit heavier
Yeah.
You know, if you self everything, and it might take a little bit more time, but at least you're like safe. I don't know, safe that your code is going to work.
Yeah.
Yeah.
I don't think you'll break anything. I mean, you might break something if you have multiple methods going that all refer back to the same variable that you set, at which point, you know, you might be changing things, you might not, who knows at that point. So
Yeah.
at that point, the cleanliness might matter a bit, but
Yeah, I get what you mean. So if you have like, if you put data frame in init function, init method, and then use data frame in multiple method in the same class, then you might run into problems, you know.
Yeah.
You know, so, but if you use self inside each method, then you're less likely to run into problems if you're using, yeah. So yeah, basically if you're using the same, can I go ahead and share again?
Yeah.
Yeah.
Yeah, like as you saw, I had like one function that didn't modify the self.df at all, and then one that did.
Yeah. So basically, if you have like multiple method like we have here inside one function, I mean inside one class, it's just safe to use self, especially if you pass in something in, if you put in data frame here and use data frame in this method and use data frame in this method, so it's just safe to use self dot.
Well,
That's what we're saying.
that first one isn't modifying the data frame at all. You're just getting the split of it. So it's basically the same as what mine did, except I'd specified the size of the split. Like that's what all that extra code was.
Yeah, I like to think of each method as its own unit, you know, so I treat it as independent. So yeah.
You can do that, but I feel it kind of defeats the purpose of classes.
Yeah, sort of in a way, you know, but yeah, I get what you mean. Sometimes you need self, sometimes you don't, but if you have a doubt, just self.
I hope I didn't confuse anybody with my little diversion there.
No, that was helpful.
You're muted, Chris.
Yeah.
Wes,
So-
I just ignored you because it was more complicated. I'm sure it's right, but I just tuned you out.
I mean, that's fair. Like, if it's too
I'm having
complex to
trouble
deal with
it,
right now.
So I'm just
Yeah.
gonna worry about the
Like,
minimum
It's
stuff.
like I said, I don't think you'll break anything by doing what she's saying. It's just,
Yeah.
I
More
feel like
code.
there's reasons to not do it.
Yeah, there are times when it's not necessary to do it. Zoom is acting up again. I think once we come back the second time, we'll upload the package to PyTest and then import it in Google Colab and see if it works. That's what we'll accomplish on the next one. So let me finish up something real quick. So self.x, you got x. Yeah, so just use self dot, you know, if you understand when to use self and when not to use self, then don't use self, you know, if you understand when to use and when not to use it. Let's just put it that way. So okay, so x equal to x dot copy, x dot columns, and then x equal to x dot drop these columns, and then s, okay. And then I could just say return x, but I'll just do return self.x just to be on the safe side. I don't know. Okay. I think this is going to work. And if it doesn't work, we'll come back and modify it. So let's go ahead and save this real quick. So pretty much we've done like majority of the stuff on this. So let's go back to the beginning. So we've done function class. Let's import from one Python file to another. And then we'll start a new Zoom because this Zoom is going to end in 8 minutes. So we'll start a new Zoom. And then when we come back, we will deploy the package, import the package into Google Colab, and try to use the package, you know. And that's pretty much going to, let's go ahead and save our progress so far. I don't think I made a lot of changes, it's fine. Let's just go ahead and continue. Let me put, so I'm just creating a new Python file. So test function. onto no dot IPYNB. So I don't know if you guys need this, but if you just do IPYNB in Visual Studio Code, it will create a Python notebook. So now you know if you didn't know that. All right, so let's see if we can import.
Wait, can you show how to do that? How to do that again? Sorry.
Yeah, so in Visual Studio Code, you click on new file, and then you say, let's say something like name dot IPYNB, and you click enter.
Cool.
Yeah. And
I haven't heard that sound in forever. 2 for 2, 3 for 4.
yeah, so oh man, Windows. So let's go ahead and say let's just go ahead and start from function. So I don't know, sometimes when I try this, it doesn't work, but let's say from function import, is it called data split data? Well, yeah, let's just do split data. Let's see. Now started, no kernel. That's interesting. So it's running on, I can change the environment for this, but I don't know how that's going to affect everything else. Let's click on yes here. Pipm, oh my God, did you guys see this? This is so cool. Did you see that? It automatically did pipenv install IPyKernel in the dev. So when I clicked yes, when it gave me like, hey, it said the data science kernel is not installed, so it couldn't do data science work from this environment. But then then it automatically installed pipenv install IPyKernel. I think that's so cool. I don't know how long it's going to take for this to occur. So this is why I use Visual Studio Code. It's so smart.
What needed IPyKernel?
This environment we're working with.
But like, what was there code that needed it, or?
Yeah, so I created a Python notebook.
Oh, that was it.
Yeah.
Yeah.
So now I know if I'm creating a virtual environment and I want a Python notebook in it, I need IPyKernel. So now you guys know too, so you won't run into error. All right, we are all set. I see now that we have IPyKernel installed, it was able to execute this code. Now we are connected right here. You can see it up here. So we need a data frame. Let's see. I have data ready. So where am I? Okay, so let's just go live. And now let's see if our function works. Split, what was the output of our function? Train test val. So let's see, train test val is equal to split data, parentheses, life, train.head. See, it works. Now let's do, just to show that it works, let's do life.shape. And then now let's do train.shape. So that, see, and then let's do test.shape. And let's do val. See, so our, we were able to, our function works, our function to split data frame, you know, from this function file, it works. So of course we could test it with target features and Rango and stuff like that. But I want to test our class real quick before our time runs out. And then when we come back, we'll do our build, you know, which will be the last thing we'll do for tonight. Unless you guys have any more questions, anything else. So let's go and do from.
Is this recording? I forgot to ask.
Yeah, it's recording.
Okay, cool.
So from class test, import, what was the name of the function of the class? So the class was called easy. Import easy. Okay. Okay, I'll do it this way. All right, let's see. Expected an indented block.
It sounds like the error is probably in the class test itself.
Yeah, that's what I'm thinking too. Okay. This right here.